Hi everyone, myself Mrs. Afroz Pathan. I am Assistant Professor in Department of Pharmaceutical Chemistry and Analysis, School of Pharmaceutical Sciences, Vistas. I am going to discuss a topic called as acidity of phenols and its effect of substituents on acidity. So acidity of phenols. Generally phenols are more acidic than alcohol and less acidic than carboxylic acid. This we will come to know by checking the Ka values. Ka is called as acid constant and Ka values are specific for each and every acidic compound. So if you see the Ka values of acetic acid, it is 1.75 into 10 power minus 5, and whereas for phenol it is 1.6 into 10 power minus 10, and for methanol it is 10 power minus 17. So for easy understanding, we will convert this Ka values into pKa values by considering the negative logarithm. So pKa value of acetic acid is 4.76, phenol is 9.98, and also methanol is 15.5. So generally, if we see the pK values which are less than 7 is considered as acids. But here, if you see phenol and even alcohol, they are having the values greater than 7. So they are almost they are considered as weak acids and little bit of a weak bases. So phenol is considered as a weak base. Sorry, it is considered as a weak acid than acetic acid, and it is a stronger acid than methanol. So the acidity of phenol is due to its ability to lose the H plus ion to form phenoxide anion, and it will give away the H plus ion. So as it is giving the H plus ion, it is considered as an acid. But phenol is a very weak acid due to its less pK value, just now how we have seen with the above concept. So phenols are more acidic than alcohols. How we can conclude that? So this is explained based upon its equilibrium reaction. Just see the alcohol reaction. So alcohol when it reacts with water, so it also will give away its H plus ion. So when it gives as H plus ion, alcohol will be converted into alkoxide and the water will be converted into H3O plus. So here alcohol and alkoxide exist as single structures, so there is no resonance for both alcohol and alkoxides. That's the reason, even though it will give H plus ion, it will give very less as it doesn't have any resonance structures for its stabilization. So alcohol is considered as a weaker acid than phenol. Why? Because phenol, when you see phenol, generally it exists in two resonance structures that is considered as Kepler structures. So, Roman number 1 and 2 is shown as phenol resonance structures, and whereas Roman number 3 and 4 is considered as phenoxide resonance structures. So both are having some resonance structures. That's the reason phenol and phenoxide are somewhat more stable when considered to alcohol. That's the reason why phenol will be considered as little more acidic. So this we will understand with a little more explanation. So the resonance structures of phenol and phenoxide, apart from the Kegley structures, are also existing. So phenol, apart from the Kegley structure, it will exist as Roman number 5, 6, and 8. The thing is, phenol is having OH, which is having two lone pair of electrons. Among the two lone pair of electrons, one of the lone pair of electron is given away towards the benzene ring, so it will form a double bond. So when it form a double bond with the first carbon, the double bond which is present between first and second carbon will be shifted onto the second carbon, so producing an anion. And also as oxygen has given its electrons towards the benzene, it will get positive charge. So here a positive charge and negative charge both are existing in phenol. And to neutralize that negative charge, there will be doing obliteration of pi electrons, and it will shift from one position to other position, so that anion which was present at the second position, now it will be shifted to the fourth position, and later on it will be shifted to sixth position to produce three different resonance structures. So totally two Kegley structures and three resonance structures. Totally phenol will exist in five resonance structures. Similar to that, if we see the phenoxide anion, in phenoxide anion already oxygen is having two lone pair of electrons. Apart from that, as oxygen is having one more negative charge, it is also considered as electrons. So among the three pair of electrons, it will be given to the oxygen, it is given to the benzene. So what is going to happen when it occur like that? So same way as phenol, a phenoxide ion will be having a negative charge at second position, fourth position, and also at sixth position. But here only negative charge is existing in the overall resonance structures. There is no positive charge which will exist in the oxygen. So totally both on both the equilibrium reaction of phenol, total five resonance structures are present for phenol and five resonance structures are present for phenoxide. But among the two, phenoxide ion resonance structure is more stable. What is the reason? Just see. So the reason is in phenol, both the positive and negative charges has to be maintained within the same molecule, making it as most unstable. As more energy has to be spent to keep the both the charges apart within the same molecule. So phenol, even though it exists in five resonance structures, for the maintenance of two charges apart, it requires more energy. That's the reason phenol resonance structures will produce an hydrate which is an unstable compound. But whereas phenoxide ion resonance structures, it has only a negative charge, making it more stable. So the equilibrium reaction between phenol and phenoxide, generally it will move towards the right side, leading to the ionization to produce phenoxide anion and also H plus ion. So that's the reason phenol is considered as more acidic compound than alcohol. Coming to the effect of substituents on acidity of phenol. So generally we know the substituents are classified as electron donating groups and also electron withdrawing groups. So if you consider the phenol and phenoxide anion, okay, when they are having any electron donating groups, so what is going to happen? So phenol it gives the electron, phenoxide ion also it gives the electron. So when phenoxide ion is giving the electrons, it will increase the negative charge on the oxygen. So it will destabilize the anion and thereby when it is destabilizing the anion, it will decreases the acidity. The reason is the electron releasing group tends to intensify the negative charge on the phenoxide. So whenever a compound is highly charged, then it is not that much stable. So it is destabilizing them. And as electron releasing group is giving the electrons towards oxygen, there is there is no need that H plus ion will go away. It will stay along with the phenoxide ion. So leading to the backside reaction is more possible. Hence, and forward reaction is not that much feasible to produce H plus ion. So thereby it decreases the acidity of phenol. So the like, same concept you can apply for electron withdrawing groups. So whenever an electron withdrawing group is attached to the phenol, so it will withdraw the electrons from the phenol. Similarly, it will withdraw the electrons from phenoxide. So whenever it is withdrawing the electrons from phenoxide, it will decreases the negative charge on phenoxide and thereby it stabilizes the phenoxide anion when related to phenol. Hence, the forward reaction is more feasible to occur and H plus ion will be easily formed. So thereby it increases the acidity of phenol. So generally, if electron withdrawing groups are there, it will definitely increases the acidity of phenol. So the examples of electron withdrawing groups like halogens, nitro group, carboxylic acid and also sulfonic acid. These are my references. Thank you.